We're on page 4 now, number 12, and this one's a bit of a chore. We first need to isolate that radical on the left. We can't isolate both of them at the same time here. You play around with it a little bit, you'll discover that on your own, but take my word for it. I'm going to leave this on the left. I'm going to add, since that says minus that, I'm going to add that to both sides. And then we'll have one radical isolated anyhow. On the other side, we'll have 1 plus square root 2x plus 6. Next, we very carefully square both sides. If I square the left side, that's not much of a problem. As we square the right-hand side, remember when we have terms being added like this, in parentheses, squared, that means, if we don't do it mentally, we write this out 2 times and multiply, or what we used to call FOIL. So the square of the square root on the left side, we just get the 3x plus 10. On the right-hand side, I'm going to write this out over here, just so I don't use up all this below space. 1 plus radical 2x plus 6 times itself. Okay. Beware of bad handwriting like mine. I almost made that 6 look like something else. So, 1 times 1 is 1. Didn't need a calculator for that. And then I get 1 times this radical, and then 1 times the radical again. So it's one of those and one of those makes 2 of those. So the middle term is 2 square root 2x plus 6. And last multiplication step, this times this, it's the square root of 2x plus 6 times itself. So it's just like when we square the square root, we get rid of the radical sign, and we just get the expression 2x plus 6. Now we start over again and attempt to isolate the remaining radical. So first let me clean up this right-hand side. I got 3x plus 10 equals, I'm going to write 2 radical 2x plus 6, and then I've got plus 2x on the outside, and I've got 1 and 6 makes a plus 7 on the outside. Let's take away 2x from both sides and take away 7 from both sides, and that'll leave this radical by itself. I'm going to take away 2x from both sides and take away 7 from both sides. And then I have x plus 3 equals 2 square root 2x plus 6. And I'm going to square both sides again. Now, on the left-hand side, x plus 3 times x plus 3 gives us x squared plus 6x plus 9. On the right side, if you want to do this the easy way, you've got this times this. Remember this old chestnut? If you've got something times variable squared, constant times variable squared, you just get the square of the coefficient and the square of the other thing. You could write this out twice and do it a long way if you need to, but I'm just going to say the squaring here makes this into a 4 and makes this into just a plain old 2x plus 6 without the radical sign, but I need to keep it in some parentheses because it has to get multiplied by the 4. So multiplying that out now, you get 8x plus 24. Okay. I can kind of hear some of you murmuring, this changing to this, that's a little disturbing. Okay, let's go over here for a minute. 2 radical 2x plus 6 squared means this. Okay? What's really going on? It's 2 times that radical times 2 times that radical. It's 4 terms being multiplied. The parentheses are sort of unnecessary now. I can change this into 2 times 2 times radical 2x plus 6 times radical 2x plus 6. And remember, multiplication is associative. I can group these together like that, and I can group these together like that. Now that becomes a 4, and that becomes a 2x plus 6. So now maybe what I did over here doesn't seem so mysterious when I said square that and we get that. Okay, oh, we're almost done. Let's get a 0 over here by subtracting 8x and subtracting 24. And if I do that on the left, I gosh darn better do it on the right. Now what do we got? X squared minus 2x minus 15. Little mini brain freeze there. And now we're going to factor this, I guess, with a minus 5 and a plus 3. X minus 5, x plus 3. On account of those numbers, multiply out to negative 15 and they add up to negative 2. So here, what's our list of solutions to this quadratic? It would be a 5 or a negative 3. 5 or negative 3. 5 would make this 0, negative 3 would make this 0, so we'd have 0 times 0 equals 0. I'm rambling now, sorry. And I think we've taken up enough time with this one. It turns out if you plug these in, they both work. So, here's one more, kind of sort of like that. Let's take a look at it. I'm going to isolate this radical by adding square root 2x plus 4 to both sides. On the next line, I've got the 6x plus 16 square root all alone. And on the right side, I've got 2 plus that, 2 plus 2x plus 4 square root. Okay. Now we're going to square both sides of the equation and then get rid of at least the left-hand radical. So the square root of 6x plus 16 gives us plain old 6x plus 16. On the right-hand side, again, let me write this out and talk us through it. 2 plus radical 2x plus 4, 2 plus radical 2x plus 4. Oh my gosh, that's sloppy. I'm sorry. 2 times 2, and then 2 times that square root, and then 2 times that square root again gives us a total of 4 times that square root for the middle term, and then the square root times the square root produces just the radicand, the stuff underneath. Okay, so the right-hand side is all this. Let me bring that together over here. And while I'm doing that, why don't I collect the like terms here, make this 8 plus 4, 2x plus 4, plus 2x. Okay. As in the previous exercise, I'm going to get this radical isolated. So I'm going to take away 8 and take away 2x from both sides. Take away 8 and take away 2x. And then we'll have 4x plus 8 equals 4 square root 2x plus 4. And I see something nice here. Do you see something nice here? Divisible by 4, divisible by 4, divisible by 4. Let's divide everything by 4, and the rest of our work will be all the simpler. Divide by 4, here, here, and here. So we get 1x plus 2, and that just cancels that. 4 times that divided by 4, we might as well just have square root of 2x plus 4. So much better. Now we'll square both sides. And x plus 2 times x plus 2 is x squared plus 4x plus 4. On the right-hand side, squaring that erases the radical sign. We get 2x plus 4. And let's get these out of here so we can have a 0 and use the zero product property to solve the quadratic. So we're going to take away 2x from both sides and take away 4 from both sides. And then we have x squared plus 2x, nothing there, equals 0. The nicest, friendliest, easiest kind of factoring, GCF factoring. The GCF here would just be x. X times x plus 2 equals 0. Now, employing the zero product property, we say if this product equals 0, then either this is 0 or this is 0. This is 0 when x is 0, or is 0 when x is negative 2. Okay? And amazingly, again, both of these numbers inserted back into the original produce a true statement. So they are both valid solutions to exercise 13. Thanks for watching. That's the end of page 4.